So this is section 1.2, part 2. In the previous part, we talked about how to find the slope of a line and looked at the 4 different types of slopes. In this part of the section, we're going to come in and start graphing lines. One of the most familiar forms to graph a line is that slope-intercept form. And that would be y equal mx plus b. And when you go to use this form, you're going to note that the m is your slope. That's the coefficient on x, and b is our y-intercept. And with those 2 pieces of information, you can graph a line. So our first example, this is example 2. The directions ask us to find the slope and the y-intercept and then graph the line. So y equals a negative 2/3 x plus 4. You'll notice it is, yes, indeed, in this slope-intercept form. So we're going to come in and pick off the slope from that equation, which is the coefficient on x, which is a negative 2/3. That, as a slope, tells us we're going to go down 2. That's, again, assigning the negative to the numerator. And we're going to go to the right 3. So I can staircase down or stair-step down this line by going down 2/3, down 2/3. The y-intercept is what's at the end of this. That's at 4. And try to remember to write it as a point. It's not a number, it's a point. So it's the point 0, 4. That's all we need to graph it. We'll start off with that y-intercept at 4. And our slope is telling us to go down 2, 1, 2, and then to the right 3. So 1, 2, 3, and I can make another point. And then if I want, I can go down 2 again, 1, 2, and over 3, 1, 2, 3, and make another point. You don't need to, but if you want a straighter line, that's all you need to do. So let's recap. It's already in slope-intercept form. That means I can pick off the slope by looking at the coefficient on x of negative 2/3. That tells me to go down 2 and over 3. The 4 at the end of this is my y-intercept, which gives me the starting point to be able to graph it. So we plotted our 4. We went down 2 and over 3, down 2 and over 3. So again, over, in our case, is always to the right. The second part of example 2 has us graph y equal 2x. So this is part B. I'm going to graph y equals 2x. Same thing again, we're going to go find the slope. In this case, the slope is the 2. I'm going to put it over 1 in order to have my rise and my run. So we're going to go up 2 because it's a positive 2 and to the right 1. The y-intercept is whatever is tacked on. Well, there is no number added on, so we're going to say it's 0. So there's an imaginary plus 0 sitting there. So our y-intercept is the origin. So we're going to start off at the origin and then use the slope. So there's the origin. From here, we're going to go up 2 and over 1. So up 2 and over 1 unit. Again, I'm going to go ahead and make a second point just because it helps me be a little bit straighter on the board. And there's the graph of the line y equals 2x. So you're going to do some graphing on the homework. The other thing we're going to do is actually write equations of lines. So in other words, if they give me the information, can I write the equation of the line? In order to do that, we need some formulas. So let's get those on the board to work with. So the first one I have, when you're writing equations of lines, so here are our useful formulas, we'll call them. Useful formulas. So we have the point slope formula, which is the one I tend to use. So the point slope formula. And it says y minus y1 equals m times x minus x1. Again, remember what you're going to be doing is giving information about the line and then have to write the equation of the line. So in this particular one, you're going to replace the y1, the m, and the x1. You also have the general form. Some books refer to this as standard form, so it just depends on what textbook you came from as to which word they use. So our 101 text calls it the standard form. Your book calls this the general form. That's ax plus by equal to c. This is actually the form that economics people tend to use, is this form when they write equations of the lines. And then the one we just saw was slope-intercept. That's y equals mx plus b. I'm going to point out the first one, point slope and slope intercept, are very well named because that's the pieces of information that you need. So to use the point slope formula, you need a point, that's the x1 and the y1, and the slope. To use the slope intercept, you need the slope and the intercept. So they're named after the information that you have to use it. So example 3 is asking us to write the equation of the line that satisfies the given conditions and express our answer in the indicated form. So for part A, they tell us that the slope is equal to 2/3, and it contains the point -1, 3. And then they want it to be written in slope-intercept form. So when we're all done, we're going to write it in slope-intercept form because that's what they asked for. So to write the equation of line, I like to start with the point-slope form. So we're given a slope, we have a point, we can plug directly into that. So I'm going to plug into that y minus y1 equals m times x minus x1. So that would be y minus the y coordinate of the point, which is 3. That's equal to our slope of 2/3. I don't know why I made that a negative because it's not. So 2/3. And then times x minus the x coordinate of the point, which is a -1. So it's x minus a minus 1. So that's y minus 3 is equal to 2/3 times x plus 1. So all we did is clean up the double negative. Let's go ahead and distribute the 2/3 in. The reason we're doing this is because because of what they want us to write the answer as. So they want the y isolated, so we need to distribute first. So that's 2/3 x plus 2/3. And then we'll add the 3 over. So y is going to be equal to 2/3 x. 3 is really 9/3 plus 2/3, which is going to give me 11/3. And there's my answer. So I've written the equation of the line that has a slope of 2/3. It passes through the point -1, 3. Example B on that problem. This time, our line contains the points -3, 4, and the point 2, 5. And now they want it in point slope form. Point slope form. Well, in order to use point slope form or even slope intercept form, in both cases, I need the slope. And they didn't give me the slope, but that's okay. We know how to find the slope. So we're going to go use the slope formula first. So our very first step, so step 1, is to find the slope. So we're going to use our slope formula, which says y2, which is 5, minus y1, which is 4, all over x2, which is 2, minus a minus 3, which is our x1. So this leaves me 1 in the numerator, 2 minus a minus 3 is 5. So our slope is 1/5. Now we can use the slope, and you can use either point. It doesn't matter. They're both going to be trouble. So let's go ahead and use the first point. So this is my step 2. I guess I should label it. Step 2. So it's y minus y1 equals m times x minus x1. That's the point to slope formula. So I'll use y minus 4 is equal to 1/5 times x minus that minus 3 is going to make that into a positive 3. Believe it or not, I'm done. Because they want it in point slope form, that's point slope form. I don't have to do anymore. I don't have to try and clean it up after that. That's all we need. I'm going to continue on. So let's see if we can graph using the intercept method. So this is example 4. And what we have this time is an equation that's given to us in general form. So general form has the x and the y on the same side, no fractions, and x positive. And they want us to use the intercept method. Well, what the intercept method is literally using both the x and y intercepts to graph the line. So to find the x-intercept, This is the point where the graph crosses the x-axis. We're going to let y equal 0. So if you think about it, if you're on the x-axis, the y-coordinate is 0. So that would be 4x minus 7 times 0 is equal to 28. Well, that's 4x equals 28, or x is equal to 7. So now I have a point, and my point is 7 for x, and y was 0. So I have the point 7 comma 0. So if I'm graphing this, which we're going to do here, we know that our graph crosses the x-axis by 6, 7 at a positive 7. Now I need to go find the y-intercept. To find the y-intercept, we're going to do just the opposite. We're going to come in and let the x equal 0. Because if I'm on top of this y-axis, then my x-coordinate is 0. So that would give me 4 times 0 minus 7y is equal to 28. Again, that's 0. So negative 7y equals 28. And we'll divide by negative 7. Y is equal to a negative 4. That gives me the points 0 for x and negative 4 for y. So 0 for x, negative 4 for y. And there's my second point. So now we can draw in our line. Hopefully yours is a little straighter than mine. And again, this was 0, negative 4, and this was 7, 0. So that's graphing using the intercepts. I didn't use the slope. Could I find a slope? Yeah, but I don't have to have a slope to graph a line. I can use the intercepts instead. And again, like I said a while ago, that the economics people prefer this form for the equation of a line. Let's graph another one. Using this intercept method. And again, the intercept method works best when you have the equation in general form. So example 5 is asking us to graph 3x plus 2y is equal to 0 using the intercept method. Okay, let's do the same thing we just did. So to get the x-intercept, we're going to come in and let y equal 0. Now, I'm going to make it even easier on myself. I'm not going to write it out because this term is 0. It's gone. So all we have is 3x equal to 0 and x is equal to 0. So now we have the point 0, 0. And this alarm bell is going off in my head. So if I'm going through the origin, I know that both intercepts are at the origin. So if I come in and try and find the y-intercept, I'm going to get the same point. So right now I'm just wasting time. I already know this, but I want to prove it to you. So we're going to let x equal 0. That would give me 2y is equal to 0. Again, x is 0. This term is 0. So when you divide it out, you'll get a y equal to 0. Same point. 1 point does not make a line. You need 2 points in order to draw that line. So you have a couple of options here. You could rearrange it and find the slope. That will work. Or you can come in and let x equal another value. Either one is going to work. You just need a second point. I think it's easiest to come in and solve this for y. So I'm going to come in and take that 3x plus 2y equals 0. I'm going to move the x. That'll give me 2y equals a negative 3x, and then divide out the 2. So I'm rearranging the form into slope-intercept form to find the slope. So now that we know that the slope is a negative 3 over 2, we can come down 3 and over 2 to get our next point. But you have to have 2 points. So anytime it goes through the origin, you need to do a little bit of extra work in order to be able to graph that line. The next example is talking about parallel and perpendicular lines. And when we move into chapter 2, we'll come back and talk about the idea of parallel lines. So it's kind of important for us. So it wants to know in example 6, it says determine whether the lines for the pair of points are parallel, perpendicular, or neither. So one line contains the point A, which is negative 2, 9, and point B, which is 1, 3. So that's line 1, we'll call it. Line 1, just to label it. The second line goes through a point C, which is at negative 4, 10, and D, which is at 3, negative 4, and that will be line 2. So let's see how much you remember about parallel and perpendicular lines. The very first thing we need to do is find some slopes. So we need to find the slope of line 1. So I'm going to call it M, and then I'm going to put a little L1 down here for line 1. So that would be 3 minus 9, all over 1 minus a minus 2. 3 minus 9 is 6. 1 minus a minus 2 is a positive 3, and we get a slope of 2, which doesn't tell me anything yet. Let's go find the slope of line 2. So we'll do the same thing, negative 4 minus 10, all over 3 minus a minus 4. So negative 4 minus 10 is a negative 14. 3 minus a minus 4 is a positive 7. Negative 14 divided by 7 is a negative 2. So I now have the slope of both of them. So I know that this one's going up 2 and over 1. This one's going down 2 and over 1. Well, in order for them to be parallel, parallel lines have the same slope. So these are not parallel because those two numbers are not the same. One's a positive slope, one's a negative slope. Perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. So that means that one's positive and one's negative, but the rise and the run need to flip. So these are neither parallel nor perpendicular. So just to give you an example of perpendicular, if one of the slopes, so let's say the slope of line 1 was 3 over 4, then to be perpendicular, the other one would have to have a slope of negative 4 over 3. And that's what negative reciprocal means. But we don't have that. So they're not parallel because they're not the same slope. And they're not negative reciprocals, making they're not perpendicular either. And then finally, at the very end of your homework assignment in the section are some application problems of lines. These are simple application problems of lines. We'll come in the next section and do some more complicated ones, specifically in the business world. So the nice thing you're going to notice about our course is pretty much all the applications we do are business oriented. They are all business oriented, which is nice. This is our last example. Example 7 says, using data compiled by the admission office at Faber University, college admission officers estimate that 55% of students who are offered admission. So 55% that are offered admission actually enroll at the university. So we want to find an equation that expresses the relationship between those who actually enroll. So y is going to be the number that enroll, and x is the number that are offered admission. So x is the number that are offered admission. And this is true for most universities. You offer admission to more than actually come. So it is a linear relationship. So this would be y equals mx plus b. I know that. The y-intercept over here is going to be 0 because if you don't offer any people admission, then you don't have anybody enrolling. So b automatically is going to be 0. So we need a slope. Well, believe it or not, that slope is that 55%. So we're going to put 5x is equal to y. So if you offer 10 people admission, then 5.5 of them will enroll. And that makes sense from what they gave us. So there's our equation for part A. So that 55% translates into our slope. B says if the desired freshman class is 1,100 students, how many should be admitted? So if I want 1,100 to enroll, how many should I admit? So they're asking us to solve this equation for x, which we'll just come in and divide by 0.55. So what if 1100 divided by 0.5 comes out to be? Comes up to be 2000. So this example is telling us that if we admit 2,000 students, 1,100 of them will enroll at our university. And that wraps up section 1.2 for us. We'll see you in section 1.3.